Welcome, class. We have made it to section 5. This is where we really start using our proofs and our reasoning to really form those logical arguments. We will be using a lot of deductive reasoning from here on out. In this case, we're going to be using reasoning using algebra. This will be a little bit easier than the other ones because you have already learned algebra, so you find it a little bit more comfortable to argue why something should be that way. So, for instance, there are 6 algebraic properties of equality. Algebraic because it's some sort of addition, subtraction, multiplication, so on and so forth. Properties because these should always be true for any real number. And equality because all of these use the equal sign. So, the first condition that needs to be had is let A, B, and C be real numbers. If they're not, this doesn't work. If they are, it works. So the number 1 here is addition property. If I look over here, if A equals B, so if I have two numbers equal to each other, then I can add C to both sides and it's still true. So if A equals B, then A plus C equals B plus C. Yep, addition property. It allows me to add the same number to both sides. I then look at the subtraction property. It probably lets me do the same thing, but subtract the same number from both sides. If A equals B, then A minus C is equal to B minus C. Yep. Multiplication property. If A equals B, then A times C equals B times C. Yep, it allows me to multiply the same number to both sides. Division property. There has to be an extra condition on this one. If A equals B, and I have a non-zero C, then I can take and say A divided by C equals B divided by C. True statement. Substitution property. This is like a replacement. For instance, if there was a substitute teacher here, there would be somebody filling in for me. So same thing here. If I have A equaling B, then I can substitute. Wow. Somebody does not know how to spell. Substituted in for any equation or expression. So I can substitute A or B in for any equation or expression. And then the distributive property, right here, if I have A times the quantity B plus C, I could rewrite that as AB plus AC. The reverse is also true. If I have A times B plus A times C, I can factor out an A and have A times B plus C. Alright, so these are all the properties. These are things I'm going to be using to justify my steps. So for instance, if in example 1 I'm asked to solve 2x plus 30 equals 75 minus 3x, and I need to write a reason or justify my step, this is what I'm going to do. The first part, I'm going to separate it into 2 columns, equation and a reason. Over here, I'll rewrite down what I started with, and I'll say that's what's given, because it was. The next thing I might do is I look over here. I like to get x all over to one side first, so I'll probably add 3x to both sides. When I add 3x to both sides, I get 5x plus 30 equals 75. Plus 3x makes it disappear over here, and plus 3x over here makes 2 plus 3, 5x. The next thing I might do is I might subtract 30 from both sides. And when I do that, 30 disappears from over here. 75 minus 30 is 45. I have 5x equals 45. And then I just divide 5 by both sides. I've solved for x. X is 9. However, I never justified any of those steps. I said what they were as I went about, but I never gave you a reason over here. Well, the first thing I did was I did addition to both sides. I added 3x to both sides. So therefore, the property I used is the addition property. Then I subtracted 30 from both sides. So the property I used was the subtraction property. Then I divided 5 to both sides. So I used the division property. I have now justified each step, and I have given a reason. Please note that the step that I take is the stuff in between here. So for instance, I did the addition between these steps, so the reason over here is addition property. It's what's changed from the step above it. Alright, example 2, I gave you a little bit more difficult equation. Negative 2 times x plus 30, quantity of x plus 30, equals 2 times the quantity of 70 minus 3x. And I need to again write a reason for each step. So first step, recopy it down, given. Always, 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 always do this. Next thing I did is I distributed. I did negative 2 times x and negative 2 times 30 to get negative 2x minus 60. Here, 2 times 70, 140. 2 times negative 3x, negative 6x. After that, I added 6x to both sides. I noticed that it was negative 2x and negative 6x. To get all the 6's on one side, I decided to add 6x to both sides, so 4x. Then, to get rid of this negative 60 here, I'm going to add 60 to both sides. I get 4x equals 200. The last step, divide both sides by 4, I get x equals 50. Sweet. However, now what I need to do is give a reason. So from here to here, I distributed. So the reason here is distribution property, or distributive property. Then from here to here, I added 6x. So additive property. From here to here, I added 60. So addition property. From here to here, I divided by 4. So division property. I've just done 2 problems where I've justified each step as I went through. There are a few different properties of equality. There's the reflexive, the summative, and the transitive properties. The reflexive property just allows me to say for any real number, a is equal to a. Yeah, a is going to be equal to itself. And for any segment, AB, length of segment AB is going to be equal to length of segment AB. Yeah, if it's the same segment, it's going to be equal to itself in length. And for any angle, the measure of that angle is going to be the same as the measure of that angle. It's kind of like as if you looked in the mirror and you saw the same thing back. Symmetric property. If we think of symmetry, how it's the same on the left side as it is on the right, we do sort of flip it here. So for any real number a and b, if I have a equals b, then b equals a. So I can have a equals b or b equals a. If I want to flip it around, what I'm using is a symmetric property of equality. Same thing for length of a segment and measure of an angle. So if length of segment AB is equal to length of segment CD, I can flip that around and say length of segment then length of segment CD is equal to length of segment AB. And measure of angle A is equal to measure of angle B. I can flip that around to make it measure of angle B is equal to measure of angle A. And the last one, transitive property, it's actually just like the law of syllogism. However, it's different because the law of syllogism is for conditional statements. However, the transitive property is for equations. So if I look at the first set here, if A equals B and B equals C, so A equals B, B equals C, then I can just say A equals C. They both equal B, so they both have to be the same. For segment lengths, if length of segment AB is equal to length of segment CD, and length of segment CD is equal to length of segment EF, well, get rid of this middle part, the length of segment CD. Length of segment AB is equal to length of segment EF. Transitive property of equality. And last but not least, measure of angles. If measure of angle A is equal to measure of angle B, and measure of angle B is equal to measure of angle C, well, that measure of angle B you can get rid of it. So measure of angle A equals measure of angle C is what I can conclude. So let's just see how maybe this would be used. In example 3 here, I want you to determine if measure of angle ABC is equal to measure of angle FBD. Show your reasoning. When I look at this diagram, the only thing I can say to be for sure true is that measure of angle 1 or measure of angle ABF is equal to measure of angle CBD or angle 3. And that's what I wrote here. It's given in the diagram. It's drawn. The next step, there wasn't anything else for me to do but say something I knew to be true. I know that measure of angle ABC is the addition of measure of angle 1 plus measure of angle 2. If I add these two together, I get the large angle for this part right here. On the reverse side, measure of angle FBD is equal to the measure of angle 2 plus the measure of angle 3. Both of these use the segment addition postulate. Angle addition postulate. I added two smaller angles to be larger. The reason I chose these two is because I saw that that's what I'm trying to prove. So I just put down some information I knew. Then I looked a little bit close and I said, hey, if I want these two to be equal, I need to get their right side to be equal. So what if I replace measure of angle 3 with measure of angle 1? Well, that would be possible because that would be substitution. Measure of angle 3 is equal to measure of angle 1, so I can just replace it. Yep, angle addition postulate are these two. So if I replace measure of angle 3 with measure of angle 1, we call that substitution. I replaced. And now that I have measure of angle 2 plus measure of angle 1 and measure of angle 1 plus measure of angle 2 being equal to two different things, this is the dominoes again. Measure of angle ABC is equal to measure of angle 1 plus measure of angle 2, which is in turn equal to measure of angle FBD. So we get rid of that middle, and we say measure of angle ABC is equal to measure of angle FBD, and my reasoning, transitive property. One causes the other, which causes the other. Alright, at this point you should be able to use properties to justify your reasoning. You should also be able to solve a problem and provide reasons for each step. You should also know the difference between reflexive, summative, and transitive properties, and be able to identify them when they are used. Till next time.